everyone, my name is Maria and I am a junior in high school. And today I'll be talking about metabolic engineering, focusing on the Morella thermobacteria. Yes. So metabolic engineering of thermophilic microorganisms is something that I found very interesting because it was a topic that I, in fact, did not know absolutely anything of, and I found it very interesting. So gas fermentation of bioprocesses and stigmas into imported chemicals, violent chemicals are not able to be economically efficiently produced. For example, acetone, which is a very common vital chemical, it is cost effective, but it is not economically effective. It is not clean. And well, acetone is a violet solvent that is used for everything from removing nail polish to clean textiles to even manufacturing plastics. And it can also be a purifier of imported downstream products. This process of acetone to produce it, it is industrial acetone produced and depends on thermochemical and phenol production via a Cuban process known as acetone butanol ethanol, or ABE fermentation. Although, as I said, it is very cost effective and widely used, it does have a risk of shortening our non-renewable resources such as fossil fuel stock. Therefore, it is on demand that we look for a more alternative process that is able to not use non-renewable resources. So a bacteria was engineered in Japan called Morella thermobacteria, and it is given the name because it has a higher boiling point than acetone, which is 58 degrees Celsius. And this process, the original process of acetone, was in 1942, and it involves converting two non-renewable resources, which is, of course, not what we want because we don't want a shortage. But more environmentally friendly options exist, including gas fermentation and bioprocesses that convert carbon dioxide, monoxide, and hydrogen into chemicals and fuels. At first, they did not achieve the desired production of acetone, but later on, after a certain amount of trials, they put in a strain of acetone to be able to produce enough acetone in order for it to be environmentally friendly. This is environmentally friendly because the waste that is made is eaten by indeed the bacteria, so it is more environmentally friendly. And because it causes us to, it is able to pave the way for more way, even though this is the first of its kind in many situations. This is the first trial that is done to do something like this with bacteria made in a laboratory. And it is not, this gas fermentation and metabolic engineering is not something that is very, it's not very accessible for many people, but it is paving the way for things, for following gas fermentation. Yes, thank you.